Hello students, let's welcome to our YouTube channel Physics for UG. Now in this video we shall state Mayer's formula for ideal gas and then for van der Waals gas or real gas. So what is Mayer's formula? So Mayer's formula is basically Cp minus Cv. What is Cp? Cp is the specific heat at constant pressure and Cp is the specific heat at constant volume. We have to find the value of Cp minus Cv for both gases. First we have to derive for ideal gas and next we have to derive for real gas or van der Waals gas. So first of all, take entropy. Entropy is a perfect differential and S मतलब entropy is a function of both T and B. T for temperature and B for volume. Entropy can be function of any other variables also, but here we took entropy S is a function of temperature and volume. So what will be ds? Entropy is a perfect differential, so you can write ds. As entropy is a function of both T and V, so we have to differentiate with T and V separately. So क्या होगा this line? So ds equal to del s by del t dt plus del s by del v dv. Take v constant here and take t constant here because this second part is differentiated with respect to v and t is constant. In the first part, entropy with respect to derivative t and v is constant. So the line will be del s by del t dt plus del a by del v dv. This is the familiar mathematical expression. Okay, so what to do next? Now this dt, divide dt or delta t on both sides. So left side part del s by del t are constant p, take pressure as constant. So del s by del t are constant b, so dt by dt is 1 and del s by del v are constant t and del v by del t are constant p. Okay, what we did? We divided dt on both sides in this equation. So in the next line, del s by del t are constant p. What will be this part? Del s by del t are constant v and del s by del v at t is converted to del p by del t at constant v. By what? By using the Maxwell's second relation. Actually Maxwell's relation, there are four relations. So del s by del v are constant t and del p by del t are constant v. This is the second one. So we use this in this part. Okay. So now the line will be and the next part multiplying t on both sides. What will be there? T, just multiply t on both sides. T del s by del t at constant p equal to t del s by del t at constant v plus t into del p by del t at constant volume and del v by del t at constant pressure. So what will be the formula? T delta s by delta t at constant p. This formula is Cp and this formula is Cv. Okay. So what is Cp? Cp is the specific heat at constant pressure. So specific the formula क्या होता है? Cp. तो Cp का formula actually delta Q by delta T at constant pressure होता है. And Cv का formula क्या होगा? Delta Q by delta T at constant volume होता है. We can replace this delta Q as TdS because delta Q is equal to TdS. This is the second law of thermodynamics. We use this here, this formula actually Cp delta Q delta T. We use this part will be Cp and this part will be Cv. So Cp equal to Cv plus T into del P by del T are constant volume and del V by del T are constant pressure. This is known as heat capacity equation. This is actually heat capacity equation. So easily you can find from this part easily we can find Cp minus Cv. If you take Cv to the left side, that will be Cp minus Cv equal to T into this line. So now we shall derive separately for ideal gas by taking the ideal gas equation and for real gas by taking the real gas equation. Let's now consider 1 mole of ideal gas equal to PV equal to RT. Actually, the ideal gas equation is PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T the temperature. If for 1 mole of gas, then N equal to 1, so the equation will be PV equal to RT. हमको चाहिए क्या, हमको क्या चाहिए, हमको हीट कैपेसिटी इक्वेशन में जो Cp माइनस Cv होता है उसको निकालना है. तो क्या क्या है फॉर्मूला. सो T इंटू फर्स्ट ऑफ ऑल डेल P बाई डेल T एट कॉन्स्टेंट V एक पार्ट और डेल V बाई डेल T एट कॉन्स्टेंट P वो दूसरा पार्ट. पहले इसको निकालना है. डेल P बाई डेल T एट कॉन्स्टेंट V. दिस वन इज फॉर आइडियल गैस. ओके, सो इसमें P क्या होगा, P इक्वल RT में P क्या होगा, P होगा RT बाई V. सो डिफरेंशिएट दिस पार्ट. डेल P बाई डेल T डेरिवेटिव ऑफ दिस P with respect to T at constant volume. So volume taken as constant, so here R also constant, volume also constant, so derivative of T will be 1 with respect to T, that will be R by V. And the second part del V by del T at constant P will be del V by del T. So इसमें V क्या आएगा, so from this equation V will be RT by P. Take derivative of V with respect to T, that will T क्या होगा 1 आएगा. The R constant, also in this case P is constant, that will be R by P. So R by V and R by P, we use these two values, this is 1 and this is 2. We use these two values in heat capacity equation. So what will be the equation, Cp is equal to Cv plus T into this part is R by V and this part is R by P. So what is the equation, we take Cv to the left side, so Cp minus Cv equal to T into this R into R equal to R square by PV, R square by PV. So Cp minus Cv equal to T into R square by PV. What is PV? PV equal to RT. This is the ideal gas equation for 1 mole of gas. We put here, all other parts are same, T R square by RT. So 1 R cancel, the remaining part is T cancel, the only remaining part is R. So Cp minus Cv is equal to R. This is our Mayer's formula, or this is the value of Cp minus Cv for ideal gas. Okay, so next move to the Mayer's formula for van der Waals gas. This is quite lengthy. Okay, for 1 mole of, let's start. For 1 mole of van der Waals equation, for 1 mole of gas, for 1 mole of gas, the van der Waals equation is P plus A by V square into B minus P equal to RT. Actually for n mole of gas, this is nRT and we take n is equal to 1 in this situation. In this case, for 1 mole of gas, we take n equal to 1. What is P? P is the pressure. What is V? V is the volume. A is the constant and B is constant. V is the volume and R is the gas constant. T is the temperature. Okay. So what will be P plus A by V square from this part? B minus B is multiplied in the left side, so it is divided in the right side. So RT by B minus B. Take this as equation 1. ओके, हमको क्या करना है, हमको डेरिवेटिव दोनों निकाल के, जो डेल पी बाई डेल टी और डेल पी बाई डेल टी दोनों निकाल के हमको क्या करना पड़ेगा, हीट कैपेसिटी इक्वेशन में डालना पड़ेगा और उसके बाद हमको आंसर मिल जाएगा. ओके, डिफरेंशिएटिंग दिस इक्वेशन 1 विथ रिस्पेक्ट टू टी at constant volume, because we need to find del V by del T at volume and del V by del T at constant pressure, because these two parts are in the heat capacity equation. As you need to derive the Mayer's formula, so you have to find these two parts. So what is del P by del T at constant V? This is P. Look at the equation 1. This is P. So if you differentiate this equation with respect to temperature, taking volume constant, so this second part, A by V square, is constant because A is already constant, and in this situation B is constant, so B is constant. So this part derivative will be 0. Derivative of P क्या होगा? Del by del T constant V, left side part. So right part will be RT by V minus B. ये था, तो होगा क्या? R constant, B constant, B भी constant. So this R by B minus B is constant. So variable part is T only. So derivative of T will be 1. So this is 1. So R by B minus B. Derivative of 1 with respect to T at constant volume. That is equation number 2. एक पार्ट हो गया हमारा del P by del T at constant V. दिस पार्ट हो गया. हमको दूसरा पार्ट निकालना है. Okay, differentiating equation 1 with respect to, look at the equation, differentiating 1 with respect to T at constant pressure. Differentiating 1, this one with respect to T at constant pressure. So pressure constant होता है, तो pressure, so first part will be 0. So second part will be A by V square. Derivative क्या होगा? A by V square. A is constant, so we took A as constant fix. So this part is 1 by V square. So remaining second part is 1 by V square. हमको इसको डेरिवेटिव करना है. तो क्या होगा डेरिवेटिव? तो V स्क्वायर का मतलब ये V टू दी पावर -2 होता है. डेरिवेटिव क्या होगा? -2 इंटू V टू दी पावर -3. उसका मतलब -2 डिवाइडेड बाई वी क्यू. So this part -2 divided by V Q. Already A is constant there. So next part is del V by del T at constant P. Derivative V को भी करना है, constant P, which is equal to derivative of equation 1 में जो राइट साइड पार्ट होगा RT by V minus B. देखो डेरिवेटिव इसको करना है, डेरिवेटिव इसको करना है विथ रिस्पेक्ट टू प्रेशर करना है, कौन सा प्रेशर विथ रिस्पेक्ट टू T टेम्परेचर करना है. तो क्या होगा? -RT by V minus B उसका स्क्वायर. ओके, क्योंकि V एक वेरिएबल होता है, प्रेशर कांस्टेंट, इसमें प्रेशर नहीं है तो V वेरिएबल होता है. तो क्या होगा? तो ये जो फॉर्मूला 1 by V minus B होता है, 1 by V minus B होता है. डेरिवेटिव ऑफ 1 by U क्या होता है? -1 by U स्क्वायर. सो इसीलिए -V दिस मच स्क्वायर डेरिवेटिव. द डेरिवेटिव ऑफ दिस पार्ट विल बी दिस वन. सो हो गया दिस पार्ट इंटू del V del T at P, because we use here EV formula. EV formula क्या? तो एक पार्ट होगा R by V minus P और दूसरा पार्ट होगा T. If you take this part as U and this part is V, we use the differentiation formula UV. डेरिवेटिव U को करना है, V को फिक्स रखना है, और उसके बाद प्लस करके डेरिवेटिव V को करना है, U को फिक्स रखना है. तो क्या होगा? R by V minus P in the second part, R by V minus is kept fixed, and derivative of T will be T. Derivative of T with respect to T, that is 1. That is 1. But in the first part, derivative of V with respect to T, so this part del V by del T at constant P. हमको del V by del T at constant P निकालना है, हमको वो निकालना है. तो उसके बाद क्या करना है? लेफ्ट साइड में एक del V del T P है और राइट में भी del V del T P है. उसको हम एक साथ लेके आएंगे एक साइड को. तो जो R by V minus B उसको R रखिए, उसको दिस पार्ट में फिक्स करो राइट साइड पार्ट में. वो जो लेफ्ट राइट में जो पार्ट है उसको हम लेफ्ट को ले जाएंगे, लेफ्ट को लेके जाएंगे. क्या होगा? तो del V by del T taken constant, this part is taken constant. So this right side part will be positive in the left side part. Okay, RT by V minus B whole square plus, that is minus 2a by bq. That is not plus, that is minus. That is minus 2a by bq equal to r by b minus b. So what is del by del t? हमको ओ वाला चाहिए, ओ वाला पार्ट हमको चाहिए. तो क्या होगा? r by b minus b divided by rt by b minus b whole square minus 2a by bq, and this part is divided in the right side, this part divided in the right side. So take this as equation 3. So what you have to do, this is equation 3 del p by del t, and in equation 2 we have del p by del t. We have to put equation 2 and 3 in the heat capacity equation. So what will be the part? The Cp minus Cv equal to T into, this is the heat capacity equation, T into del P by del T, P constant, del P by del T, P constant. So T into, from equation 2, this is R by V minus B, and from equation 3, this part will be R by V minus B, RT by V minus B whole square minus 2A by BQ. From equation 2 and 3, we put this here. Okay, next part, T into T is fixed. So the above part, this is R by B minus B, and this is also R by B minus B. So this part will be R square by B minus B whole square. So from the denominator, take RT by B minus B whole square as common from both sides. So from the first part, it will be 1 because everything is taken out. This is 1, and in the remaining part, we have to put the reverse. उसका जो रेसिप्रोकल है उसको लिखना है, क्योंकि इसमें नहीं था, हम इसको बाहर ले जाएंगे तो उसका रिवर्स हमको लिखना पड़ेगा. तो 2a by vq, the reverse क्या होगा? b minus b square into rt, such that if we multiply these two parts, this will lead to only this part. Okay, so over the remaining, this is t, and this part t is cancelled. This one r cancel. This b minus b square, this b minus b square cancel. The remaining there is only r in the above, and the below part is 1 minus 2a by b minus b whole square by rt into vq. Okay, क्या हमको करना है? This is r into 1 minus 2a b minus v minus b, this is b minus b whole square, this is b minus b whole square into by divided by vq rt. This is whole to the power minus 1 because the above part there is, this is 1 by something, so this part we can write to the power minus 1. इसमें स्क्वायर है, b minus b square, इसमें b minus b square. So now we neglect the co-volume part b. What is b? B is called the co-volume. We have subtracted, and we have subtracted this b from b, so we can neglect this b. So what will be the equation? b minus b will be only v. So 1 minus 2a b square by vq rt directly from this part. Okay, what will be the equation? Next, r into 1 minus b square and vq cancel, b square and vq cancel, remaining part is only 1v in the below part. 1 minus 2a by vrt minus 1. We use the binomial expansion here. With the expansion, if we have 1 plus x to the power 2, then the first term will be 1 plus 2x. If we have 1 minus x to the power 2, then the first part will be 1 minus 2x, because ये जो पावर होगा वो आके वहाँ पे मल्टीप्लाई हो जाएगा. This is the first part for binomial expansion approximation. Okay, similarly, if we use 1 minus x to the power minus 1, so we can write 1 plus x, because this minus 1 is multiplied with the second part. So what will be the equation? This, similarly, this minus 1 is multiplied with here. So what will be? 1 plus 2a by vrt. This is the binomial expansion approximation. So what will the result? Cp minus Cv equal to r into 1 plus 2a by vrt, and for ideal gas Cp minus Cv is equal to R. These are the two expression for Cp minus Cv or Mayer's formula for both real gas and ideal gas. Thank you. If you like this video, then you subscribe and share and like the channel. Thank you.